Hello and welcome back to another video. In this video, we're going to be working on reverse bits, the next problem in TypeScript. And in this problem, you're basically given a number, just a regular number, and you want to reverse the bits of that number. And so like if this is the last bit, this should be the first bit, and this is the last bit, and so on. But you can't just like take bits and swap, right, or something like that. I guess you kind of could, but it would be like a different way of doing it. You probably could actually take the bits and swap. But essentially, what we need to do is we need to reverse the bits. And so the problem in TypeScript is numbers are stored in floating point format, which means they have like a bit, a sign bit, a exponent, and like a mantissa, I think it's called. But yeah, essentially, the problem with that is to do bit shift, it converts the number. So if a bit is stored in, I think it's stored in 64 bits, actually. The number is stored in 64 bits. But when you do bit shifting, if you're not familiar with what bit shifting is, I'll explain it briefly. Essentially, you have two types of shifts. So let's say we have a small number like this, 0, 0, 1, 1, 1, 1. So essentially, you can shift bits to the left or to the right. Let's say you shift to the right. What's going to happen is this last bit gets chopped off, and then these bits remain. And then basically, another bit gets put in here, right? Because the number of bits remains the same. You kind of chop off the right bit. You can imagine it's like a, like a factory or something where you had things being made on like the actual main part of the factory, and then once it's made, it's chopped off, or it's like put somewhere else, and then a new thing is put on here to be made. So the size remains. But there are two types of shifts. There is a logical and an arithmetic shift. And this kind of shift in TypeScript is actually an arithmetic shift. And what the arithmetic shift does is it takes the very last bit over here and just replicates it. So in this case, it will be like this. But the problem with that implementation is if you have a number like this, what happens here is in a right bit shift, it will look like this, and then it will take the leftmost bit and replicate it, and then it will look like this, and then this will just be never ending because it'll just keep adding ones, which is a problem, right? So what you want to do to actually ensure that you only have 32 bits is you actually want to use a logical shift, which is represented like this in TypeScript. And what this one does is this one is pretty straightforward. So no matter what number you have, like let's say you even have this number, right? Obviously, you're going to have more bits than 6. But essentially what this one will do is this one will actually chop off the last number and then put in a 0 at the leftmost part, regardless of whatever the sign bit was. So it'll look like this. And this is what you want because essentially our logic is going to be to keep taking this last number and keep shifting until our number is 0. So we'll kind of walk through that with a 6-bit number. Now, you could also, if you don't care about the bits, I'll show you like another way of doing it that you don't need to do bit manipulation that kind of does the same thing. If you don't want to go into like left shifts and right shifts and arithmetic shifts. But yeah, there's also one more shift, which is a left shift, which always puts in a 0 on the rightmost side. So this is the same thing. You shift to the left. So like for this number, you will shift to the left. So it'll be 1, 1, 1, 1, 1, and then it will put in a 0 on the rightmost side. It'll just always fill that up with a 0. And we'll get rid of this. So let's kind of look how we could do this with a bit shift, and then we can see how we could do that without using bit shifts at all. So let's say we have a 6-bit number. Obviously, we're going to have a bigger number, but let's just say we have a 6-bit number in our case, and we're just trying to like reverse the bits. It's going to be reasonably straightforward. So we're going to have this 6-bit number. Let's call this n, and we're going to have another number that's going to start at 0. And essentially, all we need to do is we need to figure out how many times to do this. And you are going to want to do this. You're not going to want to do it till it's just 0. You're going to want to do it for the total number of bits. So let's say there's 6 bits. You're going to want to do this 6 times. But essentially, the operation will be you left shift this number, and then you take this right bit and you add it on, and then you right shift this number. And we'll kind of walk through how that looks. So first we left shift this number. Well, this is all zeros, so that's not going to do anything. Then you take this right bit, and if it's a 1, then you need to add it on. And if not, just leave a 0. And how do you do that? That one's pretty straightforward. You just do n and 1, if you and shift with 1, then what happens is whatever number you have, 1 looks like this. So when you and something with this, it's basically like, let's say you and this with this, it will just, what an and does is in order for it to be a 1, it has to have a 1 and a 1. So it will take every other bit, turn it into a 0, and then make this a 1, which is what you want. And so if you and it with a 1, then you will just get the number 1, right? And then you can take this number and you can OR it with a 1. And when you OR with a 1 looks like this. So when you OR it, it will just add that 1 there. So basically, we're just checking if the rightmost bit's a 1. If it is, we're adding a 1 here. So let's just kind of do that. Okay. And remember, we need to do this 6 times. So now we need to shift this to the right. So what would happen here is if we shift it to the right, and remember we are doing logical shifts, we're going to get rid of this, and we're just going to put in a 0. Okay, now we need to shift this to the left. So to shift it to the left, we will do this, right? We'll do this. Now we check for a 1 again. There is a 1. So once again, we add a 1 over here, and we shift this to the left, or to the right, sorry. So we will essentially get rid of a 1, put in a 0, which will happen, right? Technically, this 1 falls off, but it's easier to draw it like this. So you keep doing this, right? So then again, you shift your number again. So shift this number, and then check, is there a 1? There is a 1, so let's add a 1 here. And you keep doing this, right? And at the very end, this number will look like 1, 1, 1, 1, 1, 1, and this number will be all 0. So essentially, you're just shifting this number this way, and shifting this number this way until all the bits are copied. So let me explain how to do that without bit shifting at all, right? So let's just write down our steps first of all. So we shift answer left once, then check for 1 bit on the right of number, and then we add that 1 to result if it's a 1. Otherwise, it's a 0, we don't care. And then finally, we shift the number, our original starting number, right 1. We keep doing that, do this, whatever number of bits times, so bits times. So how do we do this without shifts? Just to make it a little easier, because TypeScript is annoying with shifts. So I'm going to show that as well. So the way to do that would be, let's just think about like what a left shift actually does. So a left shift, if we have a number like 8, let's say, yeah. Or actually, I guess it's going to be, yeah, sure. So a left shift adds a 0 here. So this 8 turned into 16, right? So a left shift just means you need to multiply your number by 2. That is basically equivalent to a left shift. So we can rewrite these steps in math. So multiply answer by 2. Now check for a 1 bit to the right of the number. What does that mean? So a 1 bit just means it's an odd number, right? Like a 1 bit here means it's an odd number. So do we have another way to check if it's an odd number? Yeah, we do, right? We can just mod by 2. So we can just mod by 2, and then we can figure out if it's an odd number that way. That totally works. So we can do that, and let's actually do that. So multiply answer by 2, and then here we're just going to mod by 2. Now we add that result if it's a 1, so that's pretty straightforward, right? Just result plus 1, and then, or whatever, like it would be result plus and mod 2, right? So if this is odd, it will add a 1, and if it's even, it'll add a 0. So that part's fine. Now we want to shift the number to the right one, right? Our original number. So what is shifting a number to the right one? Well, let's take a look. So we have this 8 again. If we shift it to the right, it will look like this. And so this is 4. So basically, shifting to the right is divide by 2, but let's say we have another number. Let's say we have a number like, let's just say 7, right? Is this 7 actually? Yeah. So if we have 7 and we right shift it, logically, it will look like this, which is 3. So not only do you have to divide by 2, you have to floor divide by 2, right? So what you have to do here is shift number right one means number floor divide by 2. And then bits times, pretty straightforward. So we can actually use, like I said, we can actually use this multiply, divide, and mod to simulate bit shifting. Now, it's a little bit slower, I believe, than bit shifting, because I think bit shifting is like native to computers or something. So it's just like a faster operation, but it should still be like O1. It's just like for actual performance, if you were making like a compiler or something, I think you'd want to use bit shifts. But like I said, totally fine. And I think using like this kind of implementation will be easier if you are doing this in a bunch of different languages, because the way numbers are represented and the way bit shifts work in languages are different. So it's super annoying. Like in Python, it's one way, in Java, it's another way, in TypeScript, it's another way, right? But I think this would be universal to every language. So if you want to do it this way, then that would be totally fine. And that's the way I'm actually going to code it up. So let's do that. So first of all, what we have to do is we have to make a result, right? So we can just say let result equals 0. Now we have to do something 32 times. So we can just loop. So we can just say like let I equals 0, I is less than 32. So remember what we're doing, right? So first we are shifting the result to the left. We're essentially multiplying it by 2. So we can just say result 2. Now we need to get the very last bit from the number and add that to the result. So we can just say this, and then it's going to be num, the old n mod 2. So that'll give us the last bit, right? If it's a 1, it'll add a 1. If not, it'll be a 0. And now you have to bit shift the number to the right once. And like I said, it's the same as divide by 2. So we can just divide by 2. And we remember it's a floor divide. Oh, yeah, we mapped out 4. But yeah, you can see how like this would get annoying with bit shifting, because also you can get out of bounds of bit shifting in TypeScript, because if your number is 32 bits and there are or 64 bits, when you shift, it actually converts it to a 32-bit number. So there's also that issue. That's not an issue in Python. Let's see. Oh, we need to actually return here. Yeah, let's see if we have anything else that's wrong. Maybe we do, maybe we don't. Okay, cool. So you can see it's reasonably efficient as it gets. I think if you did actual bit shifting, it would be a little bit faster, but it's still going to be the same actual complexity, and there are less issues to worry about. Yeah, so for the time here, this is going to be an O of 1 operation, actually, because this is always 32 times. So you do always want to do this 32 times. You don't just want to do it if the number is, like, until the number is 0, because if you have a bunch of zeros, like let's say you just have the number 1, right? If you just do this till the number is 0, the problem is your result will look like this as well. So you actually do need to do it 32 times, because you want to ensure that your 1 here that you take is all the way to the left. So you can't just like end it when the number is 0. Normally when you do like all these bit shifts, you normally just do it till the number is 0, but in this case you actually want your rightmost number in your original number to be 32 bits shifted in the result. So it's going to be O of 1 because we're doing this 32 times no matter how big the number is. Obviously, if your number is 0, you can break early, but that's not going to like save anything. And for the space, it is O1 as well, because we just have a result, which is one number. Right? Also, you don't count the result, so either way. We are literally not using any other variables here. But yeah, this is as efficient as it gets for this problem. So this always varies all over the place. So, but yeah, it's going to be all for this problem. Hopefully you liked it. And I think I would recommend going with this method over bit shifting in this case, at least, just because, you know, when the bit shifting is kind of weird in the language you're using, I would try to stay away from it because it can lead to a lot of unexpected results, especially if you have like an interview question here, like, because then you have to really know how bit shifting works exactly in your language, which is like they show, you know, in Java it's in 2's complement, and something else it might not be, and something else is in signed, and so on. So you can do bit shifting, but you would really have to like know in detail how bit shifting works in your language, which not everyone does. But this would be universal. So yeah, that's gonna be it for this problem, and hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.